Traveling at over 120 kilometers per hour, the formation disintegrated in a matter of seconds. In an instant, the dirt road turned into pure chaos, with motorcycles losing control and riders abandoning the route in a desperate attempt to escape to the surrounding fields. At 5:01 a.m., the Russian offensive crumbled in seconds. The first motorcycle exploded, and the rider right behind it didn't even have time to react. Then came the sound that changed everything: a growing hum. Small drones began to appear in the sky. Tunguska air defense system attempted to lock onto the targets, but faced a fundamental problem. They were too small, too low, and too fast. By the time the operators understood what was happening, it was too late. In less than 6 minutes, the entire unit was neutralized, not by heavy artillery or sophisticated missiles, but by a swarm of inexpensive drones, each costing less than $3,000. The scene reveals a brutal shift in modern warfare. Minutes earlier, at 4:46 a.m., this same unit had begun its advance in the Zaporizhia region of Ukraine. It consisted of 18 military motorcycles, forming a rapid spearhead. The mission was to cross 12 kilometers of open terrain before dawn and reach enemy trenches. The strategy was simple: trade armor for speed. While heavy vehicles would take up to 15 minutes, the motorcycles could make the journey in less than 5. Therefore, they advanced at almost 130 kilometers per hour in aggressive formation. In front, 3 riders; behind, the rest of the column. A support vehicle carried an electronic warfare system, and at the rear came the Tunguska for air cover. On paper, it seemed like an efficient combination. In practice, it turned out to be the opposite. The speed forced the formation to compact, transforming the unit into a clear and predictable target. And that's exactly what the drones exploited. The result raises an inevitable question. If 20 drones can already destroy an entire unit in minutes, what happens when there are 200? From a distance, the Russian formation appeared fast and aggressive, but the speed came at a hidden cost. Motorcycle assault units cannot disperse as effectively as armored vehicles. They need a clear path. In this case, that path was a narrow farm track barely 4 meters wide. This forced the 18 riders to stay within a single corridor. The distance between the motorcycles remained short, about 10 meters between each one. At over 120 kilometers per hour, this spacing left virtually no room for sharp turns or evasive maneuvers. Military analysts call this a target corridor. Once the vehicle in front is blocked, everything behind it piles up, and this corridor contains something even more dangerous than the pilots themselves. The third vehicle carried the Chapnik electronic warfare system, drone signals within a radius of nearly 5 kilometers. But powerful jammers have a weakness. They emit strong electromagnetic energy. Chapnik's system emitted about 17 watts, far above the speed of motorcycle radios, making it an easy target to detect. While the Russians awaited traditional threats, 21 inexpensive FPV drones, costing about $2,800 in total, were already en route, confronting a convoy protected by a $15 million Tunguska system. Each drone carried a small explosive payload, but the key difference was their autonomy. They didn't depend on remote control or GPS. They used their own vision and sensors to identify and prioritize targets. Upon arrival, the AI quickly analyzed the battlefield and identified the entire column, prioritizing what emitted the most energy, namely, the electronic support system itself. The lesson is clear. In the modern battlefield, it is not the price, but intelligence and electronic signature that determine who becomes a target first. Chapnik Electronic Warfare Unit. To the drone's sensors, it stood out like a beacon in the darkness. The software immediately classified it as target number 1. This decision triggered the next stage of the swarm logic. 5 drones were assigned to attack the Chapnik vehicle. Another 7 were kept on standby. The The remaining drones focused their attacks on the Tunguska air defense system. All of this happened automatically. No pilot, no radio commands, just code-making decisions faster than any human operator could react. Shortly before 5 a.m., the team inside the Tunguska finally noticed something unusual on the radar. Tiny signals blinked near the detection limit. At first, they seemed harmless. The return on the radar was minuscule, about the size of a large bird. In most situations, operators would ignore such contacts. Birds appear all the time over rural areas, but these objects were moving too fast. Tunguska attempted to lock onto the target, and that's when the system began to have difficulties. The radar had been designed to track aircraft and helicopters, large targets flying high above the battlefield. These drones were different. They were small. They flew less than 20 meters above the ground. At that altitude, the radar beam was obscured by interference from the terrain, trees, buildings, and topography. When the system managed to isolate a target, the drones were already seconds away, and the Tunguska team was about to learn this the hard way. The moment the Chapnik jammer went silent, the entire battle changed. Up to that point, the Russian column still had options. The Tunguska team was trying to track the approaching targets. The pilots were accelerating, hoping that speed alone would carry them through the danger zone. But the swarm had already advanced to the next stage. A drone destroyed the blocker. 20 drones were still in the air, and now they've started to organize themselves. Instead of attacking randomly, the drones have shifted to a coordinated attack pattern. Military analysts call this distributed swarm engagement. In simple terms, several small machines began to act as a single predator. The remaining drones split into 3 layers of attack. 6 drones flew higher, reaching about 90 meters above the road. From there, they could see the entire train. Their role was simple: to track every movement below. 7 drones moved to the flanks, about 40 meters high, aligning themselves with the center of the Russian formation. The last 7 drones remained low, flying less than 12 meters from the ground. They followed the dirt road itself, closing the distance behind. In a few seconds, the geometry of the battlefield changed. Drones circled above the pilots. On both sides, others positioned themselves for attack, and behind the column, several machines were already rapidly advancing down the road. The Russian pilots were now trapped in what analysts call a 3-axis kill zone. When a unit enters this space, escape becomes extremely difficult. If they sped up, they would advance directly against the drones ahead. If they slowed down, the attackers behind them would catch up. For the Russian column, speed had just become a trap, and the drones were closing in on that trap. Viewed from above, the formation no longer appeared to be composed of separate machines. It moved like a single predator circling its prey. Each drone constantly adjusted its position relative to the others, changing altitude and speed dozens of times per second. To the pilots below, the sky still seemed empty. The only sound they heard was the roar of the engines tearing through the frozen ground. None of them realized that the machines above had already calculated their exact positions, their speed, and the precise moment to attack. By the time the first pilot understood what was happening, the trap had already been set. At 5:01 a.m., it finally came to fruition. The Russian pilots were still advancing when the first attack drone dove from above. It struck the motorcycle in front. The explosion was sharp and sudden. The motorcycle spun sideways and fell across the narrow dirt road. The rider right behind it barely had time to react. At 120 kilometers per hour, a motorcycle needs more than 35 meters to stop on loose ground. There was no space for that. The second pilot collided with the wreckage at full speed. In a few seconds, the front of the column collapsed. What was once a fast-moving spearhead suddenly turned into a blocked corridor. That was exactly what the drones needed. From 90 meters high, surveillance drones tracked every movement on the road. Attack drones began diving one after another. At 5:02 a.m., a drone struck the rear of the formation. The explosion disabled a motorcycle carrying extra ammunition. Shrapnel was scattered across the dirt road. Two other pilots fell while trying to avoid the debris. Now the column was completely disorganized. The motorcycles, which were supposed to move as a single, fast unit, were now scattered across almost 300 meters of road, and that made them even easier to hunt down. A drone swooped down the side and struck a rider who was trying to escape across the adjacent field, but the ground there was soft due to recent rain. The motorcycle slowed down almost immediately. Seconds later, the drone caught up with it. At 5:04 a.m., two more drones attacked almost simultaneously. One exploded near the center of the road. The other hit a motorcycle that was trying to turn around. Tunguska team tried to react, but the radar was already compromised. The cannons never fired. By 5:06 a.m., fires were already burning along the entire length of the road. Several motorcycles were overturned. Others were still running, their engines roaring with no riders at the controls. The assault unit that had entered the corridor minutes before was no longer moving. All that remained were smoke, scattered debris, and the sound of drones circling overhead. At 5:07 a.m., the attack ceased. Smoke rose above the dirt road where the Russian column had entered minutes earlier. Pockets of fire burned among scattered motorcycles. Some engines were still running, their rear wheels spinning in the dust. But the most unsettling aspect of the attack wasn't the destruction. That was how it all happened. When Ukrainian teams later analyzed the drone data, one detail immediately stood out. There was very little human control after the attack began. The first drone destroyed the Chapnik jammer, and from then on, combat was dominated by autonomous systems. Each drone analyzed the environment in real time, movement, heat, and emissions, and updated targets several times per second, much faster than any human reaction. Even without communication or GPS, they continued to operate normally. The impact of this is enormous. A swarm that cost less than $3,000 destroyed a unit protected by equipment worth millions of dollars. This shows that, in modern warfare, cost and armor no longer guarantee an advantage. The episode reveals a profound shift. Small, autonomous drones can overwhelm traditional defenses and dismantle entire forces in minutes. And the greatest risk lies not in what happened, but in what comes next. Because if 20 drones are already enough, larger swarms can completely transform the battlefield. The logic has changed. It's not the team with the most armor that wins, but the one that adapts fastest to the new form of combat. Did you enjoy the video? Leave your opinion below. Until next time.